Imagine standing before a mirror unlike anything humanity has ever known. A mirror that does not show your reflection. Not your face. Not your present. Not even your past. Instead, it reveals the memory of reality itself. A silent archive written in light. Every faint glow within it carries a message older than civilization, older than Earth, older than life itself. The light you see did not begin its journey yesterday. Or 8,000 years ago. Some of it started moving across the universe billions of years before human beings existed. Before oceans covered our planet. Before the sun itself had fully matured. Each photon is a traveler from another age, crossing impossible distances to deliver fragments of forgotten history. And now, for the first time in human existence, humanity has built an instrument powerful enough to read those ancient messages. The James Webb Space Telescope. But Webb is not simply another telescope. It is something far stranger. A machine designed to look backward through time. Because in space, distance and history become the same thing. To look farther away is to look deeper into the past. When astronomers observe a nearby star, they see it as it existed moments ago. When they study distant galaxies, they witness events that unfolded millions, even billions of years earlier. The farther we gaze, the older the universe becomes. And Webb was created to push that vision farther than ever before. To witness the earliest chapters of existence. To search for the first sparks of cosmic structure. To uncover how darkness transformed into stars. For decades, scientists believed they understood this story. According to modern cosmology, the universe began approximately 13.8 billion years ago in an unimaginable event known as the Big Bang. Not an explosion into empty space, but the rapid expansion of space itself. A beginning so violent and energetic that matter, energy, and time emerged together. At first, the newborn cosmos was unbearably hot. Too hot for atoms. Too chaotic for stars. Only particles raced through expanding space like fragments of a reality still learning to exist. Slowly, temperatures cooled. Hydrogen and helium formed. Immense clouds of gas stretched endlessly through the darkness. Yet despite all this matter, something surprising happened. The universe went silent. For millions of years, darkness ruled everything. No stars burned. No galaxies shimmered. No light pierced the void. Astronomers call this forgotten chapter the cosmic dark ages. A universe waiting to awaken. But gravity never sleeps. Invisible and patient, it slowly began gathering matter together. Tiny irregularities grew stronger. Regions of gas collapsed inward. Pressure intensified. Temperatures climbed. And eventually, the darkness broke. The first stars ignited. Ancient furnaces blazing into existence. From them came the first galaxies, fragile collections of stars scattered through an infant universe. At least, that is the story scientists expected to see. The deeper we looked into space, the simpler the cosmos should have appeared. Primitive galaxies. Chaotic structures. Messy beginnings slowly evolving into order. Complexity was supposed to take time. Billions of years. Galaxies like our own should have arrived late in cosmic history. But when James Webb turned its mirrors toward the distant universe, something strange emerged. Something nobody expected. Regions once dismissed as empty suddenly exploded with detail. Faint smudges became vast cosmic systems. Ancient light sharpened into structure. And hidden within the darkness stood galaxies that looked impossibly mature. Some displayed organized disks. Others possessed dense, glowing centers. A few hinted at elegant structures that seemed too sophisticated for such an early era. According to theory, these galaxies should barely have existed. Yet there they were. Bright. Massive. Unexpectedly organized. It was as if astronomers had opened a history book expecting primitive villages, only to discover entire cities already standing. Naturally, scientists questioned the data. Could the measurements be wrong? In astronomy, distance depends heavily on something called redshift, the stretching of light as the universe expands. If calculations were mistaken, perhaps these galaxies only appeared ancient. Perhaps they were closer than expected. Younger than imagined. But observation after observation revealed the same unsettling truth. These structures were real. And many existed astonishingly early. Some appeared just a few 100 million years after the Big Bang. In cosmic time, that is almost immediate. Far too fast for comfort. What if the greatest mystery uncovered by the James Webb Space Telescope is not what it discovered, but what those discoveries seem to imply? Because the deeper humanity looks into the ancient universe, the stranger the story becomes. The galaxies James Webb revealed were not supposed to exist in the form we found them. Not so early. Not so organized. Not so evolved. According to long-standing models of cosmic history, the infant universe should have been chaotic. Violent. Messy. Stars forming slowly inside scattered clouds of hydrogen and helium. Galaxies should have emerged cautiously, growing piece by piece over billions of years. And yet, Webb's observations seem to whisper something entirely different. A universe moving faster than expected. A cosmos building structure almost immediately. As if creation itself skipped entire chapters. But galaxies were only the beginning. Because hidden inside their ancient light was another surprise. Chemistry. And not simple chemistry. Complex chemistry. When astronomers analyze distant galaxies, they do something extraordinary. They study light itself. Every beam arriving from deep space carries fingerprints, tiny signatures revealing what matter exists inside stars and galaxies. From these signals, scientists can identify chemical elements scattered across the cosmos. Hydrogen. Helium. Carbon. Oxygen. Iron. And what Webb began finding raised difficult questions. Some of the universe's earliest galaxies already contained heavy elements. Elements that should not have existed in such abundance. Because the Big Bang did not create them. The early universe produced mostly hydrogen and helium. Everything heavier had to be forged later. Inside stars. Through unimaginable heat and pressure. Carbon formed in stellar furnaces. Oxygen emerged through fusion. Iron appeared during violent stellar death. And when stars exploded, these ingredients scattered into surrounding space, enriching future generations of stars and planets. But this process takes time. Stars must form. Age. Collapse. Explode. Again and again. A slow cycle of destruction and rebirth. And yet Webb detected signs that this enrichment had already begun startlingly early. As if generations of stars had somehow lived and died faster than theory predicted. Suddenly, astronomers faced another unsettling possibility. Perhaps the young universe was not calm and gradual. Perhaps it was frantic. Violent. Accelerated. A place where stars ignited rapidly and vanished just as quickly, reshaping cosmic history at breathtaking speed. Then came another puzzle. One even harder to explain. Black holes. Not ordinary black holes. Supermassive black holes. Objects containing millions, sometimes billions, of times the mass of our Sun. Modern astronomy assumed these giants required enormous stretches of time to grow, slowly feeding on gas, dust, stars, and surrounding matter. But James Webb uncovered evidence suggesting something astonishing. Some supermassive black holes appear to have existed shockingly early. Far too massive. Far too soon. Like discovering an ancient empire already thriving near the dawn of civilization. The question became unavoidable. How? How could something so enormous form so quickly? Scientists proposed possibilities. Maybe certain black holes skipped normal growth entirely. Perhaps dense regions in the early universe collapsed directly into gigantic structures. Others suspect hidden interactions involving dark matter, the invisible substance believed to shape much of cosmic gravity. But the truth remains uncertain. And uncertainty is where science becomes most interesting. Because sometimes confusion signals discovery. Sometimes broken expectations reveal deeper truths. Then came another surprise. Order. The shapes of distant galaxies challenged assumptions yet again. Instead of random, chaotic forms, many appeared strangely structured. Disks. Patterns. Symmetry. Organization emerging during a period when turbulence should have ruled everything. Why did matter arrange itself so quickly? What invisible architecture guided creation? Some researchers suspect dark matter may play a far greater role than imagined. Not merely scaffolding for galaxies, but an unseen force helping organize cosmic structure itself. A hidden framework quietly shaping reality long before stars illuminated the darkness. And yet perhaps the most astonishing implication lies elsewhere. Life. Because Webb has detected carbon-rich molecules drifting through deep space. Complex compounds considered among the building blocks of biology. Ancient chemistry scattered across unimaginable distances. This means something profound. The ingredients for life may have existed billions of years before Earth. Long before our oceans. Long before dinosaurs.